You've learned about acids and bases and what those are. You've also learned about pH and how pH is a measure of how acidic or basic a solution is. Today we're going to talk about indicators. An indicator is an organic compound that changes color at a specific pH. Some of them change more than one color at different pHs. There's some very common indicators, for instance red and blue litmus paper, which come in containers that may or may not look like this. And I have these here, red litmus and blue litmus paper, small pieces. There's also pH paper, which you can see contains a color chart to indicate the pH. Sometimes it looks like this and has a color chart like this to indicate pH. We also have other things like universal indicator or phenolphthalein. We have phenol red. We have brome cresol green, brome phenol blue. We have alizarin and alizarin yellow R in these last two columns. There are also other things like indigo carmine or brome thymol blue. You can even make your own out of purple cabbage by boiling purple cabbage and collecting the juice, and it changes a wide range of colors. It's almost as good as pH paper in that respect. Now what I'm going to do is I'm going to place various pHs in the rows going across. So pH 2 I'm going to put in every row or in every column going across in this row, and then pH 3 and pH 4 and so on, and we're going to observe the color changes of the various indicators. Notice right now that all of the indicators are the same color. So phenol red has this yellow color from the top all the way down to the bottom. Brome cresol green the same way. So let's begin with pH 2, which is the most acidic solution that I have here. So there's no change on the blue litmus paper, but notice the red litmus, the blue litmus paper changes to red. Our pH paper also turns red. Universal indicator is red. The phenolphthalein, which is a clear solution, remains clear. Phenol red changes to a yellow color. The brome cresol green also yellow. The brome phenol blue is yellow. The alizarin and the alizarin yellow R also remain yellow. So now let's take a look at pH 3. What I'm using are buffer solutions which maintain their pH even when they're mixed with something. So this will remain pH 3 even when it's mixed with other compounds, or it will try to. Notice that the blue litmus paper has turned red. We have an orange color there for our pH paper. No change for phenolphthalein. The phenol red and the other indicators here have changed kind of a yellow color, although the brome phenol blue looks like there may be a transition there going on. So let's try pH 4. We can see now that the brome phenol blue is turning a purple color. Still no reaction from our phenolphthalein. pH 6, so we're getting close to a neutral solution here. Still a little bit acidic. And now lastly we have pH 7, which is our neutral solution. Notice that the red litmus stayed mostly red and the blue litmus stayed mostly blue. So a neutral solution can't be told from just one litmus paper test. You have to test with both, and if neither one changes, then it's neutral. Now we're getting into the basic realm with pH 8. Notice that the red litmus paper has turned to blue. Now pH 9, our red litmus paper, blue again. There's a slight pinkish tinge, you can't really tell, to the phenolphthalein there. pH 10. Beginning to see some color changes in the alizarin. 11. And finally 12. Of course the pH scale goes to 14, but 12 is the highest buffer solution that I have. So that's as far as this chart goes. Alright, put a little more of the alizarin there. Wasn't very much to begin with. There we go. So, as you can see, the red and blue litmus paper, they're all red up to about pH 7, and they're all blue from 8 and beyond. And right at 7 is where we kind of have that in-between color. That's why you always use both, one red and one blue. And if neither change color, you're at 7. If the red turns blue, you're a base. And if the blue turns red, you're an acid. The pH paper is good, as is the universal indicator, for being able to look up an approximate pH off of a color chart. There's a color chart for universal indicator. Phenolphthalein, you can see, is a clear liquid until we get to about pH 8 or 9. This is a very faint pink. It's difficult to see in the picture, and then it's very vivid pink as we get further down. Phenol red changes around pH 6. You can see it beginning to get kind of orange and then pink. And all of these changed color at different points. Now it's very important to understand that with the wide range of these organic compounds that are available, you can use 2 or 3 to narrow down your pH very well. If you already know that something is in the basic range, you can use these compounds like alizarin and alizarin yellow R to narrow down where they are in the basic range. Some of these others change up in the acidic range, but you always need to have a couple of different indicators to tell. So for instance, let's suppose I was testing something that turned phenol red yellow. Well, that only tells me that it is somewhere in the range of 2 through somewhere about 6. But if it turns brome creosol green to a blue color, that tells me that it's in this range. Well, if I've tested with both colors, I can be pretty confident that a good yellow and a good blue are going to be somewhere right there, which is pH 5. So it's always important to test with more than one indicator that change in the range close to where you think the pH might be. And again, you can use red and blue litmus paper or phenolphthalein to tell if it's an acid or a base. All of the indicators have a range that's usually well known. For instance, indigo carmine changes between 11.3 and 13, and it changes from blue to yellow. Whereas brome phenol blue changes between 3 and 4.6, and we can see that right here. Here's 3 and here's 4, and that's where it's going from that greenish to a purple color. So you just choose your indicators based on the range, and then by comparing the colors of 2 indicators, you can usually narrow the pH down to a specific pH.